Hello everyone. Today we are going to start with the fifth lecture of the first unit of surveying 2, right? Today we are going to study about traversing. It is theodolite traversing. We are going to use theodolite while computation of traverse. Okay. So what we are going to study today is what is theodolite traversing, why we should go for theodolite traversing, that is purpose, and traverse by deflection angle and traversing by included angle. There are various methods that the way you can do the traversing. So first we'll understand what is traversing. Okay, right? Traversing is the one of the simplest and the most popular method of establishing controlled networks in the engineering surveys. Now, what are these controlled network stations? You can see, right? You can see the stations here, right? These stations are helpful. Like these various stations. This area covers to a larger extent, right? So these are not been once. Sometimes they are may not be able to see also. They are so far. In that cases, these station points will become a reference point for to work to start, or reference to get some detailed surveying. So these control points will put a boundary to your survey work, right? This is one of the principles that I studied, like part from whole to part, right? Survey should be done from whole to part. This is a whole part, right? This is a whole part, and you're going to do small parts in this area. So traversing becomes important to fix the main control station points or major control points, right? Then comes the minor, which are inside the traversing. So it is one of the simplest and the most popular method of establishing control points. Now, what does this traversing consist of? Right? A traverse consists of series of straight line connected successively at an established point along the route of survey. The point defining the end of the traverse line is called as traverse station or traverse point, right? Can you see this picture here, right? You can see there are series of lines like station A to B, C to B to C, C to A, D. These are all lines where two lines meet at a point. That end point is called as traverse station, or it is called as traverse point, like station C, station B. It is in between the two lines. It is connecting two lines, so that point is called as station point, or it is called as traverse point. Okay. Understood. Why is traverse necessary? To establish the control network points in the engineering survey. And traverse is nothing but a series of connected lines, straight lines. It is nothing but it is a series of straight lines connected successfully. And these two lines connected at a point is called as traverse point or a station, right? It's called as traverse station. Now, so how to do the traverse? There are two types of traverse that we do. One is the open traverse and another one is the closed traverse. So we'll first understand what is closed traverse and what is open traverse. Then we'll study how to construct these traverses, right? How to set up these traverses on the actual ground. We'll study it. Right? So the first one is open traverse. Can you see here that there is a station point A, right? B, C, D, and E, right? Why this is called as open traverse? the starting point A and the ending point E are not meeting at the same point. They are not closing to each other. And the last point is an unknown point. The last point is an unknown point. We don't know where it is. Okay, what is reference point? We don't have any reference to it. Okay, the last end point is at unknown position, and they don't close with the, and it doesn't close with the starting point. You are not closing from the where you have started, and the end point or the terminating point is unknown for us. Okay, where it is, at what distance it is, we don't know. So this is how the open traverse looks, right? Understood what is open traverse? The point whose position may be known or unknown, but the terminating point whose position is not known. We might be knowing the position of the starting point, but we will not be knowing the position of end point. And also they don't meet at a same point, or they don't meet at a starting position. The last point doesn't meet at the or coincide with the starting position, so that is called as open traverse, right? And these type of open traverse are used for projects like road work, canal work, railway lines, shoreline protections, boundary lines of the rivers, pipelines, right? Where it starts at one end and ends at another point, where there is no relation from the start point and the end point. There is no connection of start point and the end point. In such cases, this traversing becomes useful. In the case of when you are going to do the survey along the river, you want to construct a road, or you want to construct you want to do the survey for the canal works. So pipeline distribution networks of the water supply and sanitary works, right? Or for the gas lines, you can say. So for all these things you require surveys, right? For that survey you're going to do what? You are going to do the open traverse, right? You're going to do the open traverse. Open traverse originates, right? The open traverse originates from the point whose position may be known or unknown, but terminates the point whose positions are not known, right? Next is the closed traverse. Now, what is this closed traverse? The word itself tells what it is, right? When a traverse, this is your starting point, right? A is a starting point. Then we go to the B, C, D, E, and the last point is joining the starting point, right? The last point E is joining again to the starting point. The point where we started the traverse, at that point itself it is closing, and it is making a closed polygons. Right? Any shape it is making, but it is a closed shape trying to make. The open, it was open, it was not connecting or not coming to the same starting point. In this case of closed traverse, the starting point and the end points are the same, and we may be knowing the position of A. So means the end point and the start point are known to us. The start point and the end points are known to us. This is very much important to understand when we call it as open or when we call it as closed traverse, right? So when we are going to use this closed traverse, you're going to use this closed traverse when you want to measure the area of some confined boundaries. If there is an area which has particular shape and size, confined boundary is there. We can't move away from that particular point. So that area which is a controlled point area where, okay, confined boundary is there, whose area can be calculated through this closed traverse, right? And one more thing is to establish the ground control points for photogrammetric surveying. What happens, when you are doing a photogrammetric surveying, means through the drones or through the aircraft, okay, you are going to set up an photos cameras over the drones and the aircraft, through which the flying drones or the aircraft will capture the uh, pictures of that land where you are going to survey. Or to get the knowledge about, or to get the information about that land, you are going to use the drones or the aircraft to capture the photos. Through that photos you are going to find out the areas, main points. So to do this photogrammetric surveying, we have to confine ourselves to the area in which, or the area which we have to do the survey. For that purposes, first we have to set up the boundary of that area in which, or for which we have to do the photogrammetric surveying. This becomes important, right? To confine ourselves for an area. We can't do the surveying for unnecessary land. Wherever it is necessary, there only we are going to use, so that we save the, it becomes economical and save the money itself, right? So when a traverse originates from the position, okay, known position, and also terminates to the same position, it starts from that position where the position is known and ends at the same position whose position is known, so that is called as closed traverse. What it is called as? It is called as closed traverse. Now, next is how to set up or how to construct the Theodolite transfers. There are two methods. The first one is included angle method, and the second is the deflection angle method. Right? This method is suitable for the land surveying, and this method is preferable for the closed traverse method. In this method, included angles between the two successive lines are measured. What we are going to do? We are going to measure the angle between the two successive lines. Now, what it is? What are these two successive lines? Right? You'll understand how to calculate the included angle. What is included angle? You have to first understand. Included angle means, if I show you, if this is the first line and the successive line means continuous line here like this, these are the two lines, right? So when you measure the inside angle, this is called nothing but included angle. It is called as included angle. This is your successive line 1 and successive line 2. Between the angle between the two successive lines of a traverse, okay, you're going to measure. Now how you are going to measure, that will explain you here. Now what you're going to do is, you're going to fix a point at a station as a station point, right? So this becomes your station point from where you're going to set up a theodolite, okay, and in which direction you are moving to proceed. You are going to measure the distance and measure the distance, and then continue with the second successive line. As the nature of ground, it depends upon the nature. It is not the same every time. Depending upon the nature of ground, you're going to as you set up here the station point, right? You're going to set up the station point. You're going to bisect the point. You're going to bisect the point P, right? Point P through the telescope. You know what are the temporary adjustments and how to bisect a point, right? Once you bisect the point, that point has been fixed, measuring the distance correctly, whatever required, right? Once you fix the point P, shift the instrument to the point P here. Now, what you're going to do is you're going to set up a new station. It is from O to P. You have intersected the point and you have set up the station point. From P, in whatever angle or in whatever direction the next point is, you're going to bisect that point accurately and measure the distance, and then you're going to set up a station point. But your theodolite is still on. Your the theodolite station is on the P itself. Now what you're going to do is, again you are going to bisect the point O, right, and move in the clockwise direction, right? Once you bisect the point O where your reading angle, vernier angle is 0 0, now you have to loosen the upper clamp and tighten the lower clamp, right? Then move your telescope towards the point Q and bisect the point Q here, right? Bisect the point Q. Now when you turn the telescope, your angle also turns, right? Your angle is shown. When you bisect the point Q, now tighten the clamp, upper clamp, so that there is no again change in the angle once you bisect the point Q. Then you will get that will give you the included angle. In the same way, you have to continue for the other points, right? Again for the another point. See, you can see here. In the same way, the whatever process I have told, you're going to bisect the further point and then measure the angle with respect to the previous point to the forward point, right? Same we are going to do and calculate the inner angles. So what will happen when you calculate the inner angles and the distances? It helps you to find the area of that traverse. And one more thing is, it becomes very easy to get details of the minor traversing, right? Minor points. It helps you to get the details from the minor point, right? See, you can get the interior angles like this. And the direction of traversing is anti-clockwise. What it is? Direction of traversing is anti-clockwise because we are moving in this direction, right? You are moving in this direction, so it is anti-clockwise direction. So this included angle is useful only for the closed traverse, right? It is useful for the closed traverse. Now next is traversing by deflection angle. This method, or you can say angle by deflection, traversing by deflection angle, is useful when you're doing the line survey or longitudinal surveys, like survey for the roads, railways, canals, right? Where the traverse line makes a small deviations, where there is not much of the deviation or the angle, where there are small angle made by the lines. Okay, that is called as deflection angle traversing, where you're going to use the deflection angle here. The same thing I have told you how to construct or set up the uh, deflection angles, right? So you're going to use the same method, okay, and then you're going to start with the open traverse deflection angle by traversing, right? This is your magnetic bearing, right? This is your bearing PQ. This is your bearing PQ from the point Q. Now what you're going to do is, now once you measure the bearing of line PQ, you're going to set up the station, or you're going to set up your theodolite at the point Q, right? You're going to set up the instrument at Q, and you're going to bisect the point P. Once you, with the help of the compass, uh, you're going to set up the put the bearing PQ and fix the point Q. Once you put you use compass to uh, get the bearing of line PQ, right? So once you get the bearing of line PQ, you're going to set up the theodolite at point Q here, right? At this point Q, right? Once you set up the point station theodolite at the point Q, you're going to bisect the point P. You're going to bisect the point P, right? Once you bisect the point P with the help of the theodolite telescope, you are going to transit the telescope by 180 degrees. Transiting means what? Turning the telescope in 180 degrees. So you need not tell every time that it is 180 degrees. Transiting means turning the telescope along the vertical plane. Okay, along the vertical plane, right? Along the vertical plane at an angle of 180 degrees, so that your telescope moves in the opposite direction, in this directions, right? In this direction. You got it? Right? You're going to extend, once you transit the telescope, you're going to extend it, and then what are you going to do? You're going to deviate by given deflection angle, right? You're going to deviate for a given deflection angle. From there, you're going to deviate or make an angle of deviation with respect to the previous line, right? This is your PQ is the previous line. You have extended it, and with respect to that point or that reference line, you're going to make an deviation, and that angle is called as deflection angle, right? So I'm not going into the procedure how to uh, okay, how to use the theodolite step by step, because we have already told you about the procedure, how to set up the deflection angle, how to get the included angles, right? So we are going to use that same methods here, but we are going to use it in the realistic manner, right? Then again you have to do the same thing repeated by changing the phase, right? So you're going to measure that deflection angle. Again you're going to once you measure the bearing QR, you're going to set up your theodolite at the station R, right? And you're going to what you're going to do, you're going to bisect the point Q, and again transit the telescope at 180 degrees, and then get an angle of deflection with respect to the previous line, right? This is what you get as an angle. this is what you get as an angle. That angle is deflection angle. With the help of the deflection angles, you are going to set up the, or you are going to construct the open traverse, right? You have, whenever you are going to use the theodolite for making an angle or measuring an angle, you have to do it both face right and face left itself. Okay, you can't have any shortcuts here. You have to do it 2 times with the help of the face right observations and face left observations, right? Same thing, you have to do it again. So this is how what we have studied today in this class, that how to do traversing by included angle and by deflection angle method, right? And what is traversing? What are the types of traversing? And which traverse you are going to use in which type of projects? This is all we are going to study today in this lecture, right? That's all for today. We'll meet in the next lecture.